Welcome to Arid Online Academy. In this video, we're going to consider the properties of acids. By the end of this video, you'll be able to describe the characteristic properties of acids as reactions with bases, metals, carbonate, and of course, the effect of acid on indicator paper. The first reaction we're going to consider is the reaction of acid with base. Acid can react with base to form salts and water. So, a given example of a base, let's look at an example of a base and an acid. Let's take hydrochloric acid. Hydrochloric acid, you can see hydrochloric acid having your hydrogen ion and your chloride, ion. So we have hydrochloric acid plus a base. Let's take copper oxide, copper 2 oxide. The two of them will react together to form copper chloride and going to form copper chloride and water. Copper chloride and water. So it's essential that you are able to write the chemical equation for this reaction. So we have HCl aqueous plus copper oxide. Copper oxide is an insoluble base, so that gives us copper 2 chloride, Cl2 plus water. Then you balance the equation. Okay, so we have 2 here. It's going to balance the equation. You may be required to write the ionic equation for this reaction. So essentially here we have 2H plus. Break down your hydrochloric acid into its covalent component, aqueous plus chloride. We're going to have 2Cl minus aqueous. Then here we are going to be having copper oxide solid because it is solid, so it is not going to dissociate. Then we are going to have your copper 2 plus aqueous plus 2Cl minus aqueous, and of course this is liquid. It's not going to dissociate, so it's going to stay as air. So essentially you could cancel the spectator ion. This is unchanged, so the overall equation here will be 2H plus aqueous plus copper oxide, and that gives us copper 2 plus aqueous plus water. So this is the ionic equation that represents this reaction. This is a neutralization reaction, a reaction in which acid reacts with base to form salt and water. So it's a neutralization reaction because the product of the reaction, combination of this product of the reaction will be neutral, having a pH of 7. So it's a neutralization reaction. Okay, we have a substance with a pH less than 7. We have another substance here with a pH greater than 7. So if the two of them come together to react together, we have a neutralization reaction, and the product of the reaction is expected to be 7, the neutral pH. So let's look at another example. You need to recall that your base could either be soluble base, or you have insoluble base. Insoluble base could be soluble or insoluble. If your base is soluble, we call it alkaline. Of course, so other insoluble bases are just, base. So a base is an oxide or hydroxide of metal. So We have cited an example of a reaction of acid plus base to give salt and water. We use insoluble base. So let's cite another example of a soluble base, an alkaline. So let's say acid now plus alkaline, just to balance things up, is going to form salt and water. So let's take example of an acid. Let's use sulfuric acid in this case. Sulfuric acid plus sodium hydroxide that will give us sodium sulfate. When a salt is formed, when a acidic hydrogen in an acid is replaced by a metal or an ammonium ion. That is when a salt is formed. So we have water. So let's look at the chemical equation, symbol equation, plus sodium hydroxide, aqueous, both of them are soluble, so you can say aqueous is going to form sodium sulfate. That is sodium sulfate. Go and review the writing of formula. Then we have water. So looking at this equation, whether it's balanced, so this is 2 sodium here, we put 2 here. So this equation is balanced. We have 2 moles of base against 1 mole of acid. We have 2 sodium, 1 sulfate, 2 hydrogen here. We have 4 hydrogen here. So we can balance this up this way and everything is balanced. So you could write the ionic equation for this particular reaction of acid and alkaline to write the ionic equation. So let's break this down into 2H plus SO4, 2 minus, this is aqueous, plus this is aqueous, so you can dissociate. We have 2 sodium ion, aqueous, plus hydroxide ion, aqueous. So that gives us sodium sulfate is aqueous, so we have 2 sodium plus aqueous plus sulfate, SO4, 2 minus, aqueous. Then of course this is liquid water, so it's not going to break down. You have H2O and liquid. So let's remove the spectator ion. Don't forget, a spectator ion is an ion that remains unchanged in the reaction. So when it is a reactant and when it is a product, they remain the same. So we can cancel that out. You can take sulfate out here. So let's write the remaining ions. So we have 2 hydrogen plus hydroxide, and that gives us water. So this essentially is an equation that represents neutralization reaction. So you can see neutralization reaction is essentially a reaction between an acid and a base to form water, salt and water. So this represents a summary or a shorthand for the neutralization reaction between a base and an acid. Now let's consider another reaction of acid. Number 2. Metal can react with acid to form salt plus hydrogen. So a typical reaction of a metal, if a metal is dropped in an acid, let's assume that we have a lump of magnesium dropped in an acid. What's going to be observed will be effervescence. You see bubbles of gas, as you can see in these test tubes being formed. That indicates the formation of a gas, and in this case the gas would be hydrogen. So we'll talk on how to test for the gas that is being produced shortly. So let's look at the typical example. Magnesium plus an acid. Let's take nitric acid. Nitric acid is going to form magnesium nitrate. A salt is formed when the hydrogen and acid is replaced by a metal or ammonium, and in this case it's replaced by a metal. So we are going to be forming magnesium nitrate plus hydrogen gas. So that is seen as effervescence in this reaction. So writing the symbol equation, so we have magnesium plus nitric acid HNO3, that's going to be aqueous, to give us magnesium nitrate, that's going to be 2. Go and recall how to write chemical formula. This is a gas. So let's check if the equation is balanced. With 2 here, we just balance the equation. You may be asked to also show the ionic equation for this particular reaction. So the process of doing that, magnesium is solid, so it's not going to dissociate. So you still have your solid plus your aqueous nitrate is going to split into 2, your hydrogen ion plus your nitrate ion, aqueous. So 2, just to balance this up. This 2 here refers to both hydrogen and nitrate, and magnesium nitrate here, this is aqueous, so you would expect that this will ionize or split or dissociate in solution. So we are going to be getting magnesium 2 plus aqueous plus nitrate, aqueous, and that is 2. And of course, we have the hydrogen, hydrogen gas here. Okay, so if that is the case, the next thing we'll do from subsequent example is that we'll cancel the spectator ion, the ion that remains unchanged in the reaction. Your magnesium is changed from magnesium metal to magnesium ion, so that's a change. Your hydrogen ion is changed from ion to element, gas, hydrogen gas, so that is a change. So we have to let others remain. So essentially, we're going to be getting magnesium plus 2 hydrogen to give us magnesium 2 plus aqueous and hydrogen gas. So this represents the ionic equation for this reaction between a metal and an acid. So you could try as many examples as you could lay your hands on. So let's talk about how to test for the gas that is formed. How do you test for the gas that is formed? How do we ascertain that this gas is hydrogen? So in this reaction, when a metal reacts with an acid, the product is salt and hydrogen. So basically, you need to recall the tests for hydrogen. Okay, to test for hydrogen, you have to introduce or you insert a lighted splint into a tube, a test tube containing hydrogen, and this will be your test. So what will be your observation? Your observation for this particular reaction will be a squeaky pop sound, something like pop, pop, pop. That's a squeaky pop sound. A squeaky pop sound indicates that hydrogen is present, indicates the presence of hydrogen. So that's how to test for hydrogen. So let's look at the next reaction of acid. Acid reacts with carbonate, number 3. Acid can react with metal carbonate, and if that reaction takes place, it's going to form, we're going to form salt plus water plus carbon dioxide, salt, water, and carbon dioxide. As you can see in this particular test tube, you have a metal carbonate reacting with an acid. The effervescence is something you can't miss. It fizzles. That's effervescence, release of gas. You can see a lot of bubbles. And in this case, when the gas is formed, the gas travels through this tube, goes into a delivery tube, and to test for the gas, to be sure that the gas is, carbon dioxide. So we have a reagent here called lime water. Lime water is essentially calcium hydroxide. So when carbon dioxide is bubbled into lime water, the solution becomes milky. The solution becomes milky. It changes from colorless to what? To milky color. From colorless to milky color. That's how you test for the presence of carbon dioxide. So essentially, your carbon dioxide turns lime water milky. The carbon dioxide turns lime water milky. So this is the simple test for carbon dioxide. So let's look at a typical example of acid plus carbonate. Acid plus carbonate. Let's take sulfuric acid. Sulfuric acid plus a metal carbonate. Any metal carbonate. Let's choose potassium carbonate. Potassium carbonate. So that is expected to give us potassium sulfate. Sulfuric acid forms sulfate. Potassium sulfate, plus carbon dioxide and water, plus carbon dioxide plus water. So let's look at the symbol equation here. We have sulfuric acid aqueous because it's soluble, plus potassium carbonate. All sorts of potassium are soluble. So we have potassium carbonate. It's going to be aqueous. So that gives us potassium sulfate. Potassium SO4 is going to be aqueous, plus carbon dioxide plus water H2O. So we seek to balance this equation. The equation seems to be absolutely balanced. So to write the ionic equation for this particular reaction, we can follow the examples of the previous example that we gave to write the ionic equation for this particular reaction. So let's consider the reaction or the effect of acid on litmus. Effect of acid on litmus and methyl orange. Now, if litmus comes in two colors, red and blue litmus. This is a red litmus and this is a blue litmus. So if you have a solution of an acid, this is a solution of an acid. If you dip a blue litmus paper into an acid, the blue litmus paper is going to turn to what? It's going to turn red. Now, there is no need for you to moist your litmus paper before using it to test for an acid. You only moist your litmus paper if you want to test for the pH of a gas. Because if the gas is acidic, acid anhydride, the gas will behave as an acid only when it's dissolved in water. And so you need to wet your litmus paper before you use it to test for the pH of a gas so that the gas can dissolve in the water of the litmus paper and it shows its effect as an acid. But in this case, there's no point moistening your litmus paper. Just drop the litmus paper into the acid. So blue litmus paper in acid will turn red. So if I dip this blue litmus paper maybe to half level into this acid solution, the blue litmus paper turns red. That indicates that this solution is an acid, while the red litmus paper remains what? Remains red. So acid turns blue litmus red, and red litmus remains red in acid. Very simple. So very simple. If you use your universal indicator paper, if you dip your universal indicator paper into a solution of an acid, so your universal indicator paper does not only tell you that the solution is acidic, the universal indicator paper tells you the exact pH of the solution. So you take the paper and match it with the color on the universal indicator chart. Then you'll be able to tell the pH. So this reads the pH, while this reads the color on the universal indicator paper. You can see an example here where the blue litmus paper is dipped into an acid and it turns red. Now for methyl orange, methyl orange has a pink color in an acid. You can see the color in an acid, the pink color or red color in acid, while in base it has a yellow color in base. So that is how to test for the acidity of a solution using the indicator paper. So far we have been able to see the reactions of acid. We said acid can react with metal to form salt and water. Acid can react with carbonate, metal carbonate, to form salt plus water plus carbon dioxide. Acid can react with base to form salt plus water. Acid can react with alkaline. To form salt plus water. These are the reactions of acid. Kindly subscribe to this channel and click the notification icon so that when I drop a video like this, you'll be the first to be notified. See you